Comparative study of cryptographic algorithms. Abstract. This paper pinpoints on the resource utilization and analysis of the performance of different cryptographic algorithms. Security is the most challenging issue that involves computers and communication and has to face prime risks. To overcome this security concern, numerous cryptographic encryption procedures exist and do compare 7 different algorithms, namely DE, TripleDE, Blowfish, Twofish, AES, and RSA. Keywords: cryptography, symmetric, asymmetric, TripleDE, Blowfish, Twofish, AES, RSA. 1. INTRODUCTION. The conversion of plaintext to ciphertext is encryption and the reverse process is decryption. The type and length of the keys depends on the encryption algorithm and the measures of security needed. The use of single key pertains to encryption and decryption in symmetric, else it is asymmetric. With this key, the message is encrypted by the sender and is decrypted by the recipient. The key security is a challenge. 1.1 Cryptography Goals. The security system secrecy is ensured by a set of security functions which are the aim of the system. The goals are as listed below. Authentication. The sender identity and the receiver identity is verified prior to sending and receiving messages. Confidentiality. Only the people who are authenticated can read and interpret the message. Integrity. The message is secure from any modification between sender and receiver. Non-repudiation. Neither the sender or the receiver cannot mistakenly refuse of sending a message. Service reliability and availability. The availability and the services gets affected when intruders attack these secure systems. 1.2 Data Encryption Standard, DE. Data Encryption Standard, DE, is a symmetric key block cipher. DE was found in 1972 by IBM using the data encryption algorithm. Apparently no weakness has been found yet and the only risk is brute force. It was accepted by the government of USA as standard encryption algorithm. It has a key of 64 bits and the size of the block is 64 bits. As restriction has been put by NSA regarding usage of DE with 56-bit key size, so DE avoids 8 bits from the 64-bit keys and then compresses the 56-bit keys derived from 64-bit keys to encrypt data in a block size of 64 bits. 6. Algorithm. 1. In the initial step, the plaintext having 64-bit block issued it over to an initial permutation, IP, function. 2. In the plaintext the IP is performed. 3. Left plaintext, LPT, and right plaintext, RPT, are the parts of the permit block, produced by IP. 4. Each LPT and RPT perform 16 rounds of encoding. 5. At last, LPT and RPT are united and a final permutation, FP, is performed on the merged block. 6. A 64-bit ciphertext is originated. A. All keys being independent. B. Key 1 and Key 2 being independent keys. C. All 3 keys being identical. Due to the technological advancement, many intrusions and possibility to break the encrypted code was detected. To improve the security, the encryption is performed thrice, 3 DE. 1.3 TripleDE. TripleDE was formulated to reinstate the original DE algorithm for, which hackers learned to defeat with comparative easiness. Earlier, TripleDE, the widely used symmetric algorithm, was the recommended standard in the industry. In each 56 bits, TripleDE uses 3 individual keys. The standard encryption method is similar to the original DE but applied 3 times to increment the encryption level. The attacks of brute force in DE as well as the attack of meet in the middle occurred in 2 DE can be removed. The advantage is proven reliability and longer key size reduces the time taken to break DE and eliminates the shortcut attacks. 6. Triple Data Encryption Algorithm, TDEA, and the standard ANSX 9.52 have block cipher with secret symmetric key and have a block length of 64 bits and the size of the key is 56 bits, 112 bits, or 168 bits. 3 DE was designed because DE algorithm, developed in the 1970s, uses 56 bits key. The security in effect provided by 3 DE is just 112 bits because of the meet in the middle attacks. TripleDE executes 3 times slower than DE, but security aspects are more if used properly. The procedure for encryption and decrypting is the same, except the reverse execution. In DE, data is encrypted and decrypted in 64-bit chunks. For DE, the input key size is 64 bits and the actual key adopted by DE is of the size 56 bits. The parity bit is the least significant, rightmost, bit in each single byte and is set such that there is every time an odd number of ones in each byte. The bits of parity are avoided, so 7 of the most significant bits of each byte are used, emanating in a key size of 56 bits. Hence the effective strength of the key for triple-DA is literally 168 bits due to the fact that the three keys contains 8 parity bits each that is not used during the process of encryption. Algorithm. Run DA 3 times. ECB mode. If K2 equals K3, this is DA. Backwards compatibility. Known not to be just DA with K4 has 112 bits of security, not 3x56 equals 168. Triple-DA algorithm uses 3 iterations of common DA cipher. It accepts a secret key of 168 bits that is divided into 3 keys of 56 bits. Encryption adopting the first secret key. Decryption adopting the second secret key. Encryption adopting the third secret key. Encryption, C equals E3, D2, E1, M. Decryption, M equals D1, E2, D3, C. Using decryption in the second step and during encryption, the algorithm provides backward compatibility within the usual DA algorithm. In these cases, the first and second secret keys or the second and third secret keys are the same key combinations. C equals E3, D1, E1, M, equals E3, M. C equals E3, D3, E1, M, equals E1, M. Hence, it is sensible to apply 3 DA cipher with a secret key of 112 bits. In this case, first and third secret keys are the same. C equals E1, D2, E1, M. Triple-DA is beneficial because it has an enormous sized key length, which is longer than most key lengths affiliated with other encryption modes. DA algorithm was replaced by the advanced encryption standard and triple-DA is now considered to be obsolete. It is derived from the single DA, but the method is used in triplicate and includes 3 subkeys and key padding whenever necessary. Keys must be increased to 64 bits in length. Known for its compatibility and flexibility, can easily be converted for triple-DA inclusion 6. Triple-DA has short and weak encryption keys and has shorter block size. AES has a better encryption mechanism and hence the performance. 1.4 Blowfish. Blowfish encryption algorithm needs a 32-bit microprocessor with 1 byte for each 26 clock cycles. Blowfish holds 16 cycles. Each round consists of XOR operation and a function. Every single round comprises of key expansion and the encryption of data. Key expansion is generally used for making the primary contents of one array, and data encryption uses a 16 rounds Feistel network methods. 4 plaintext and key are the inputs of this algorithm. A 64-bit plaintext taken is divided into 2 32 bits data, and at each round the given key is expanded and stored in 18p array and gives 32 bits key as input and XORed with previous round data. Then, for j equals 1 to 14. XL equals XL XOR pi. XR equals F, XL, XOR XR. Swap XL and XR. After the 16 rounds, swap XL and XR again to undo the last swap. Then, XR equals XR XOR P15 and XL equals XL XOR P16. Finally, merge XL and XR to obtain the cipher text. The encryption and decryption is precisely the same process, except that P1, P2 so on until P18 are applied in the reverse order. Blowfish algorithm minimized the number of cycles and each single round is introduced new modified. In the Blowfish there are 64 bits, the bits are partitioned into 32 bits and there are 4 S-boxes and each S-box contains 32 bits. The algorithm is designed with 2 S-boxes connecting with XOR and other 2 S-boxes connects with XOR, and then from the 2 XORs added then from there get key plaintext. 1.5 Twofish. Twofish is a popular algorithm for encryption regularly used in cryptography. Twofish originates from Blowfish algorithm. Twofish is a 128 bits block cipher capable of manipulating variable length key up to 256 bits. 2. The phrases used in Twofish are 1.5.1 Feistel network. Functions are transformed to permutations. Horst Feistel 9 invented this design of Lucifer and propelled by DA. The constituent of Feistel network is the F function. It maps an input string to an output string using a key 2. 1.5.2 Diffusion. A minimal change in the plaintext affects many bits of the cipher text to maintain convolution between plain and cipher text. Diffusion is attained by executing a certain permutation and carry out a functional operation. 10. 1.5.3 Confusion. The relationship among the cipher text and subkey can be made complex by creating confusion by handling relations. 10. 1.5.4 S-boxes. An S-box is a table-driven nonlinear replacement function used in almost all block ciphers. The input size and output size respectively of S boxes change and will be created randomly or algorithmically. 7. 1.5.5 Mds Matrices. A maximum distance separable, MDS, 7 code is a linear mapping from the elements of the A and B field over a stipulated field, thereby creating a composite vector of A plus B elements, which has the property of the minimum number of non-zero elements in any vector which is non-zero is 8 least B plus 1/8. Reed-Solomon, Rs, error-correcting codes are known as MDS. An inevitable condition for AXB matrix to be MDS is that all mixture of square submatrices, procured by discarding rows or columns, are non-singular. 1.5.6 Pseudo-Hadamard Transforms. A Pseudo-Hadamard Transforms, PHT, 7 is a simple operation that mixes and runs quickly in software. It is applied for diffusion. For given two inputs A and B, the 32-bit PHT is defined as A0 equals A plus B mod 232, 1. B0 equals A plus 2B mod 232, 2. 1.5.7 Whitening. Whitening 7, the method of XORing key material prior to the first round and beyond the last round. It was observed that whitening substantially increases the difficulty of key search attacks against the remainder of the cipher. 1.6 RSA. This is public key encryption algorithm developed by Ron Rivest, A.D. Shamir, and Leonard Adleman in 1977. It is the well-known asymmetric key algorithm for cryptography. It may use to provide both secrecy and digital signature. RSA applies the prime number to generate the public and private key based on mathematical fact and taking the product of large numbers together. The algorithm implements the block size data where plaintext and ciphertext are integral values between 0 and n1 for some values of n. The length of n is observed to be 1024 bits or 309 decimal digits. Apparently two distinct keys are used for encryption and decryption purposes. The sender knows encryption key and receiver knows decryption key. Algorithm. Choose large prime numbers R and S such that R equals S. Compute n equals R asterisk S. Compute F, Rs, equals, R1, asterisk, S1. Choose the public key E such that GCD, F, N, E, equals 1, 1EF, N. Select the private key D such that D asterisk E mod F, N, equals 1. So in RSA algorithm encryption and decryption are performed as encryption. Calculate ciphertext CT from plaintext message M. Such that CT equals M caret E mod N. Decryption M equals CT caret D mod N equals M caret Ed mod N. 1.7 Advanced Encryption Standard, AES. U.S. government and different other organizations have acquired the Advanced Encryption Standard, AES, algorithm as a reliable standard. 1. It is highly efficient in 128-bit form. The algorithm uses keys of 192 and 256 bits for heavy-duty encryption purposes is quite considered sealed to all attacks, with the exclusion of brute force, which strive to decipher messages using all possible combinations in the 128, 192, or 256-bit cipher. The experts of security trust that AES will be finally addressed as the actual standard for encryption of data in private sector 1.5. Algorithm. 1 sub-bytes. A nonlinear transformation is a substitution of bytes for each byte of the block. 2 shift rows transformation iteratively shifts, permits, the bytes inside the block. 3 mix columns transformation binds the 4 bytes together thereby forming the 4-term polynomials and multiplies the polynomials with a fixed polynomial mod, x caret 4 plus 1. 4 add round key transformation along with the data block will add the round key. The iterated transform, or round, in most ciphers, generally have a fistal structure. Normally, in this structure, the transitional state bits are transposed without changing the value to another position, permutation. AES lacks a fistal structure but have 3 distinct invertible transforms based on the wide trial strategy design method. 3. Conclusion. Cryptographic techniques and tools do play a vital role in designing emerging network security technologies. Among the discussed 5 algorithms, AES is best in terms of energy consumption, performance, and resource utilization. AES algorithm is brisky, and is best adapted for use in both hardware and software environments.